Hello, everybody, and welcome to Sparring Partners. Today, we're going to talk about fiber sensing in subsea cables, but other other types of fiber as well, which for me is a new topic that I came across in a recent sparring partner with Per Kangru, and he mentioned that, and I thought, well, that's really interesting stuff. And so now we have the opportunity to spend a little bit more time and really nail it. Like, why is that? What is it about? And why is it useful? And if you are like me, well, I've been really looking at sensing in wireless for a long time. I think it's a huge opportunity. And so it's kind of good to know that it's not just wireless, it's all the whole telecom infrastructure. And I have the pleasure to have as our guest today, Andres Chavarria, and he is the Fiber Sensing Development Manager at VIAVI. So he really works on this, and he has been doing this for a long time. And so he's a great person to talk to. So Andres, thanks a lot for being with us today.
No, thank you for having me, Monica. It's a pleasure always to try to reach new audiences. Again, it's a new technology within the telecom world, but it really has been deployed already in other areas for many years. So right now, I'm hoping we can learn more about the common needs on the industry and how can we take advantage of these tools.
So, okay, so why don't you tell us first how you got into the telecom and VIAVI? So you've been working on this for a while. So what were you doing in sensing before?
Yeah,
Or
so I was very different. So my background is actually earthquakes. So I've always been involved in monitoring earthquakes. Then I was working on monitoring oil and gas infrastructure with different types of sensors. And particularly within oil and gas, there was a very big push to use fiber optic as a sensor to monitor pipelines and to monitor wells. So that's what got me started into changing from traditional sensors of motion, traditional sensors of temperature, and use the fiber as a tool to take measurements in very unusual environments, hostile environments, which would be inside of wells or next to pipelines. And then we were able to show that we could use that same fiber in a telecom network to do other types of smart city work, to do other types of environmental work. So again, right now, I think over the last few years, we have shown that there's many things that we can do with that same fiber that it's letting you and I communicate today. We can use that same fiber to say, well, I can use it to detect leaks in pipelines, or I can use it to detect when someone is approaching a cable and wants to cut it. Well, I can use my sensor to detect that as almost as a perimeter intrusion detection tool that allows us to prevent a fault. And I think that's something very important about fiber optic sensing, that it is not a technology to detect faults. I think we have shown with all of our fiber testing equipment that we have been using for decades that we're very good at detecting a fault, but the intention of these tools is really prevent the fault. Prevent if it's a subsea cable, maybe prevent trolling or prevent an anchor from damaging a cable. If it's a terrestrial network, preventing construction along a cable route that all of a sudden disconnects a city or a town for a couple of days. So again, there's many aspects that really touch our day-to-day operations within telecommunications. But and not just that, is not just preventing those faults, but at the end of the day, we have these massive fiber optic networks, and these networks coexist with our infrastructure. They coexist with gas pipelines in cities. They coexist with water pipelines in cities. And if those fibers are next to those assets, we can actually use those fibers to add additional services out of those fibers. So I think there's another opportunity to really take advantage of something that it's already in the ground. And again, by using the fiber not as a tool to transmit data, but to sense the environment around that fiber, to sense whatever is happening as far as construction, vibrations from construction, temperatures. I live in Los Angeles and we had massive fires early in the year. Well, we could have used those fibers that are on transmission lines, on OPGW cables, for monitoring an increase in temperature that would have helped the fire department to say, well, there's the origin of a fire. So again, how can we be more proactive about using these cables for other benefits?
Yeah, and I say, well, fiber is everywhere, and increasingly so. So it's and you don't need to install new fiber to do the sensing. That's a huge advantage because wherever, and in fact, fiber is more likely to be where you have something of value. You don't have it necessarily in the middle of the desert. Obviously, the desert is not valuable, but if there is nothing around, probably there is no fiber or not much. But where there is an asset that is valuable.
Exactly, exactly. And look,
So
at the end of the day, putting the fiber itself is fairly simple, and something that is very cool about this technology is that all of a sudden we can connect. For example, I mentioned I come from earthquakes, so I'm in California. We have earthquakes,
Mhm.
and right now a lot of the work that is being done for early warning systems is to
Mhm.
take advantage in places where we cannot have sensors. We're using telecom fiber and say, well, we're going to have an instrument 100 kilometers away. We're going to detect things earlier so we can alert a society that there's something happening. Just taking advantage of an
So that's
existing
really
network. And
cool.
there's
Yeah.
millions and millions of kilometers of fiber. So that's the big opportunity here.
Absolutely. And yeah, I say, well, even if you can put sensors, would be hugely expensive because every sensor would just track one thing or. Okay, so why don't we go to kind of the basics of it? How can you use fiber to sense anything?
That's a great question. So similar to what we do in our fiber testing, where essentially we're going to send a pulse of light, and then we're going to look at the attenuation. We're going to look at the reflection of that light as it propagates through that fiber. So what is going to be happening is that we're going to be sending thousands of light pulses down those fibers. And what will happen is that we're going to be essentially looking at the differences between each one of those pulses. So we can send light maybe at 1 kilohertz or at 10 kilohertz, depending on the modality of the sensor that we're using. And essentially, we're going to be looking at very, very fine variations in the backscatter light that makes it back to the receiver. So basically, these instruments, which we call distributed sensors, or sometimes we call them interrogator units, fiber test heads, different ways to refer to these, but they basically work as a transmitter and as a receiver. And we're really just tracking, again, very, very small fluctuations in the backscatter light. And those small changes are going to be as a result of temperature and are going to be as a result of mechanical deformation on the cable, vibration. So at the end of the day, the fundamental physical measurement that we're tracking with this is that whenever the fiber gets elongated or compressed, it's going to change the amplitude and the phase of our light. And that is what we're going to be tracking with these devices. So it could be that someone starts a bonfire close to a cable, or it can be someone starts to jump a couple of meters away from a cable. It's in all cases, it's going to make the fiber stretch and compress, and it's going to change how the light amplitude and phase will change from the eyes of that interrogator unit. So
So
that's
if you yeah, so if you get like there's something wrong going on. But how do you know exactly? Because what I understand is that you can actually track exact location. So how do you
Mhm.
know where that is and how far ago can the interrogator unit or whatever you call it from the place where that happens? And if you have a signal that says something is not right, but what do you know what that is? I
That's
mean, is it like,
many
you know,
important questions there. So I'll start first with the localization. So
mhm,
Usually, we're going to have the fiber paths. So all of those fiber routes are something that are part of our fiber monitoring systems. Usually, will account for those fiber paths. And what these boxes have that is very particular is that we use a very narrow line with lasers with very, very precise timing. So we know exactly when the light pulses go out, when we know exactly when the light is going to be coming back. And simply using the refractive properties of the fiber, we can basically calculate with the time, the distance from where the different events are. So we call this distributed sensing because in a sense, we are going to be turning, let's say, 100-kilometer fiber into potentially 100,000 sensors. So every meter, I'm going to be detecting any type of fluctuation around that specific channel. So sometimes we may go to longer spacing, sometimes with shorter spacings, but again, all of that is tracking the time at which our light pulses are traveling from the fiber. So all of a sudden we are on a subsea cable. We start to listen for a boat. This boat, we start to hear the engines, the vibration basically propagates a pressure pulse over the water column, and we are start to hear it sometimes a good distance away from where you need to be on top of the fiber. And then let's say there's going to be an anchor that gets dropped. Well, that's going to generate again a pulse in our system. We're going to detect it in those places that are closest to that anchor from the fiber. And that we're going to be using different algorithms to identify those patterns. So, for example, we're using a lot of machine learning, where essentially we have a library of patterns for anchor drops. We have a pattern for a mechanical excavator. We have a pattern for someone opening a handhole. So what we're going to be doing is using these AI approaches. We're going to be listening to a lot of data. We generate a lot of terabytes of information per day, and we're going to be processing all of this in real time. So as soon as the fiber hears something, it's going to go through this recognition, and this I mentioned right now, acoustic events like an anchor drop, but it could also be a temperature increase or maybe a ground deformation that makes the cable stretch. So again, all of those events, we have different libraries depending on the distributed sensor that we're using. And basically that alarm is going to be sent in real time to a NOC. So basically the NOC will receive that alarm and say, oh, there's an anchor drop close to my cable at such location. Do I call the Coast Guard? Do I call some other response team? Do we need to reroute traffic from that cable? Again, with the goal of reducing downtime in our network. So again, all of that is very automated, and we're constantly adding more and more events to these libraries. As I mentioned, the technology has its civilian uses. The provenance was, again, oil and gas, for example, pipelines, where essentially we would use the fiber placed along the pipeline to detect leaks. Again, we don't want to have an environmental disaster, so we're going to be monitoring 24/7 that someone is not tampering with the pipeline, that there is no natural corrosion, that all of a sudden you have a pipeline leak and then you have a disaster. And so again, that the whole philosophy behind this technology is to have a real-time notification system that allows the operators to act hopefully before there is a problem. And
And
there's
I guess
different
here, yeah.
processes.
No, this is really interesting because as I say, it's all real time, but also you do need, like I don't know, like 20 years ago, it would have been really hard to do because you'd have to recognize the signature of an event. So you might have been saying, okay, there's something weird here, but how do you know what that is? Where that, that kind of, and now you can basically save the data. So if you know that anchor was dropped, that was the kind of pattern, then you can improve because you can learn
That's
on.
correct. That's
So
correct. And
gonna
it's
be
really
getting
just a matter
better.
of,
Yeah.
yeah, and it's a matter about label because each fiber tells a story. So whenever you put a fiber in the desert, you may have, I don't know, maybe coyotes or maybe some other
Mhm.
animal that is going to generate a signal. So again, for us, it's very simple. We're going to have an alarm, likely an alarm, but for that alarm to not become a false alarm, we just need to label it and say, well, it is some animal in the wilderness. It's nothing to be concerned about. So again, we can basically, all of these notification systems have different levels of alarms that we can flag and say, well, this is a red, this is an amber, this is a green alarm, so that the operator can
Yeah.
respond accordingly.
Yeah, because otherwise it'd be very expensive if you every time there is something odd, which I'm sure is probably all the
Yeah,
time.
and you're gonna send, yeah, at the end of the
Yeah.
day, imagine you're a telecom company, and then you're gonna say, well, there's something happening at kilometer 73.2. Go, you need to go send a crew to go check it out. Well, that's gonna be a cost. So we do need to be able to identify that event as best as we can,
Mhm.
so that even the operator knows what to take to the field. Imagine that if the operator doesn't know if the cable is aerial or if the cable is underground, well, what type of crew are they going to take to service a cable? So we can use sensing basically to even answer some very fundamental questions on the topology of the cables. Are they exposed? Do we have a lot of tension on the fiber, on the cables themselves
Mhm.
that could potentially put them at risk? Let's say if you have like an ice storm, or if you have lightning strikes. Again, these are all things that we can detect with sensing, that again can help the operator be more proactive about the management of their assets.
Yeah, absolutely. So recently, and that's actually how I learned about it from Per, as I mentioned before, is in the context of subsea cables, where clearly they're very valuable. No, they're very valuable assets, but you want them to work because when they don't work, you have a real problem. And to fix them is very hard if you don't know what the problem is, but also you want to prevent it. And there are cases where it might be malicious. So people might want to do it on purpose to cut those cables.
Mhm.
But
Yeah.
clearly, that's kind of like a more recent kind of issue with the old geopolitical things. But then there is other applications. So maybe can you start talking from that and then tell us about what
Yeah.
other use cases you
No, and
mentioned
that's
earthquakes
that's
and all sorts of other
yeah, you
things.
bring a you that, that's a super important topic. Certainly, a lot of our communications nowadays, the subsea cables play a very, very important role. It's like every other month, or probably every month, there's a cable cut somewhere in the planet. There was just one a couple of days ago in the Red Sea, Baltic, and yes, certainly if we were more proactive at listening, certainly we will be able to say, well, is it a bad actor or is not a bad actor? Well, by regulation, every boat needs to have their transponder on and say, well, these are my coordinates. I'm this boat. I'm navigating in such waters. If they turn it off, the beauty of the fiber is that the fiber continues to listen. So the fiber continues to detect, oh, there's this boat may be turned off their transponder, but we can still see where it's going. We can still track it. So that's one way in which certainly we can at least try to weed out if it's a bad actor, or if it's not or if it's something normal. But for example, just to talk about this recent example from the Red Sea, when I looked at the coordinates of the cable, the cable is very close to a small submarine canyon
Mm-hmm.
in the middle of the Red Sea. So like it's very close. And we do know that some of the mechanisms that can uh, damage these cables can be something like a submarine landslide. So all of a sudden you have ground movement, and maybe the cable will get on
Mm-hmm.
the strain. Again, there's been a couple of cases like that. West Africa comes to mind, where essentially that has happened. So using sensing, we actually can also identify that type of vulnerability and say, well, the ground is doing something, the cable is getting strained for whatever reason. We have data to basically support or our assist our forensic, all of our forensic work. Um, because again, as you mentioned, these cables are very, very expensive to service. If you take a long time detecting the fault, basically you're talking into thousands, probably close to $1 million in servicing some of these cables. So it becomes very important because you need to send a vessel to do some testing, then they need to do all the maintenance, so it's downtime. These vessels don't come cheap, particularly for the bigger cables. So again, it's an expensive enterprise. So any minute that we can save and ideally prevent a fault with this, I think it's definitely very, big value added on an asset that it's already laying in the bottom of the ocean.
Yeah, and whether it's a bad actor or not, you still have to fix it. So
Hmm.
that's a value regardless. But then if it
Yep.
is a bad actor, you are more likely to kind of see where that is and what's happening because you know it in real. I mean, knowing in real
Yep.
time obviously helps you because you can see who's around and
Yeah, and look, sometimes, and again, when I talk about the understanding the vulnerabilities of the cables, I mean, it can, in many cases, the cables need to be buried, so they're going to be trenched, and they're going to
Mhm.
put rocks on top of these cables, so we don't want them to be exposed, because that's when they're going to be damaged easily. And what we can do is basically we even have a diagnostic where we can say, well, the cable in the bottom of the ocean, it's showing. All of a sudden, we can detect the depth. We can track the depth of burial of those cables, and say, well, this cable is getting exposed due to the currents, due to the
Mhm.
just to the physics of the bottom of the ocean floor. You have it's a very dynamic environment, so we can track all of those processes. So if the cable starts to show up, well, in the past we used to run an ROV, just a little submarine, go run the lines and make a check. In this case, we actually can use data that is generated on a minute by minute basis and
Yeah.
see where the cable is, so the operator can be proactive and do some maintenance, maybe go back, throw some rocks at the cable path, so again it is not exposed. So again, this is part of
Mhm.
the change in philosophy, how we maintain not just subsea networks, but I would say also even terrestrial networks. How do we become more proactive at maintaining these critical assets? There was a large cable cut over where I live in Los Angeles. Uh, in just a couple of minutes, there was a cable cut, 13 cables, 2,600 fibers. This is something that happened over Father's Day, and I guess everyone was in there having their grilling their meat or whatever, so it was not as disruptive. But if that cut had happened in the middle of the week, I know there were a couple of hospitals that were disconnected. The 911 system was down also in some parts of the city as a result of 2,600 fibers that went down as a
Yeah.
result of vandalism. So,
Yeah,
so
no,
again,
yeah. So yeah, so subsea cables are sort of a special case in a way, but yeah, you can do it anywhere, and fiber gets,
mhm.
again, either it's bad act or vandalism or not, doesn't matter, but it happens. I mean, no,
Yeah.
it,
Mhm.
it does matter, but regardless of who is doing it, what the cause is, you still have to fix it,
Yeah.
and you need to
Yeah. Yeah.
fix it quickly, and it's expensive to fix. So if you know where to go, when to go, obviously that
Mhm.
helps.
Yeah.
Said that, there's a lot of other things that you can monitor that has nothing to do with the assets, right? I mean, so you don't
Mhm.
only monitor the fiber itself, use the fiber to
Mhm.
monitor fiber, but to actually understand, like, is it, earthquakes and other
Mhm.
things. What are the use cases there?
Yeah, so there are multiple use cases. So the technology, as I mentioned, has been around for already many years. So temperature sensing has been around for a few decades. Again, mostly for monitoring things like oil wells. Later on, we started to monitor power cables. So there's a lot of right now where a lot of work where we essentially use the fiber to monitor the current output from substations. So again, just by tracking the temperature along the cables, we can track that. But you can think in an urban environment. We're going to have conduits where you're going to have your fibers, maybe thousands of fibers by different network operators. Next to those, you're going to have conduits that also are going to have very likely natural gas. In the heating systems that again are going to be transporting different types of gases or fluids. So what we can do is again in that type of context, those fibers that are close to those, we can actually use those to monitor the neighboring pipeline, and there's been a lot of work that's been done on that area. I've also have very nice examples of heating ducts that are transporting hot water, and using the fiber, we can actually detect when there is a leak of hot water using a telecommunications company. So using a telecommunications cable. So those are increasingly used examples of that neighboring fiber tracking something that is in the same vicinity of that cable.
Mhm.
Sometimes, again, those assets will have, sometimes there's pipelines that will have a fiber optic connected to it with that specific purpose. But more and more, given that we have such large fiber optic networks, if you have a good control on the location of the fibers and if you have good control on the location of the utilities, you can try to see, well, I can use fiber A to monitor pipeline A, or I can use fiber A to monitor the power cable A in that specific location. Because again, there is a lot of also applications for utilities, as I mentioned, not just for the dynamic line rating, but again, other types of environmental sensing where we can track for vulnerabilities maybe on area lines. Again, area lines, transmission lines are going to have fiber, sometimes in the conductor, sometimes in the ground wire, in the OPGW. So we can use that fiber to not just transmit data, but to look for potential ice accumulation on the power line so that the power company can be more proactive. I would say, well, we have an ice storm. We probably should go and clean some of the ice before these lines snap. And all of a sudden we have a big blackout. So that can be
Yeah.
one area where that intersection between fiber optic transmission and utilities really goes hand in hand.
No, yeah, and this is really, quite interesting because wherever you have any utility, you typically have fiber. However, if we look at it from the cable operators, the telecom, oftentimes they do not own that fiber. So, it's the utilities that have laid fiber along wherever they're going. So how should we think about the monetization opportunity, which comes up with for every technology, anything you do is like how to
I know.
monetize it, like, right? That's the okay. So in this case, you can imagine that if I own a cable, wherever that is, I can sell whatever data on top of it. It's an advantage for me as the owner of the cable because it's gonna
Mhm.
be like I'm gonna reduce my OpEx, basically.
That's correct. And I think
So
here the
that's an
opportunity would
easy
be,
one. Yeah.
yeah, no, no, certainly I think for the network operator, the opportunity there is to, well, first, and I think hopefully we'll accomplish that with this conversation, is bring more awareness that these tools are available. Because basically what would happen is that the operator of that fiber can say, well, I know that my routes are overlapping with your power cables that are in a conduit
Mm-hmm.
and or to my pipeline. So
Right.
potentially, and I could think how that conversation between the utility and the operator and say, well, as a network operator, I have my sensing devices. I am detecting leaks. Well, I can probably sell that leak detection service for a pipeline.
Yep. Mhm.
We're taking advantage of that asset. Or let's say if it's a cable that it's overheating, it's let's say a power cable. All of a sudden, I'm using the fiber to detect maybe the onset of a fire. So again, I have an alarm system where I can potentially notify maybe the cities and governments if those cables are close to infrastructure, maybe like bridges, maybe that could be the end user would be the transportation company, which again, it's another area that I actually haven't touch as much, but certainly these tools we're going to be detecting vehicles, we're going to be detecting all types of stuff. So if the cables are along highways, if the network company owns those cables and it happens to go through some highway, well, we can actually monitor the traffic on that highway and provide a service to the city and say, well, guys, we can detect traffic jams, we can detect if there's changes in road conditions that are making people speed up or slow down. Uh, Train, again, we have a lot of
Mhm.
conduits that are going along rail lines. So again, there's a lot of applications that historically have used fiber sensing to detect trains, but historically what has happened is that, for example, transportation, something like a train company, deploying these, they will use their own fiber to do this. But again, there's a lot of other fiber available that if
They
we
don't work.
have that collaboration between the utilities, between that critical infrastructure and the telecom company, we can basically marry them and say, well, there may not be a need to install more fiber because you already have fiber nearby.
So in this case, let's say that I'm a cable operator or even a utility or whatever. So I need to put the hardware to detect.
Mhm.
So do they, I mean, at that point, is it pretty trivial to actually understand what's going on, or you need to have a different provider that is able to kind of analyze the data
No,
that
I
you
would
get?
say no. I would say there's these systems for the most part have a good level already. I mentioned a library of events, so
Yeah, you
there's a
did. Yeah.
little bit of intelligence against. Unfortunately, we do generate a lot of data. So very early on in the history of this technology, we had to do as much interpretation of the data in real time as was possible.
Hmm.
We're constantly enhancing the algorithm, constantly adding more events to the library. But for the most part, let's say if you have a fiber access at a NOC or at some network hub, it's as simple as connecting the instrument, listening for a little bit.
Hmm.
There's usually, depending on the modality that we're using, if we're using temperature or strain or acoustics, where you may need to spend a little bit more time listening to the environment. Because imagine that you have maybe a fiber that goes 100 kilometers of fiber path, and then you're going to be passing the desert, and you're going to be passing bridges, and you're going to be passing the middle of town. All of those three environments are going to be very different. So we
Hmm.
do we do need to basically include some of the mapping capabilities to make sure that uh, we are not getting false alarms from the bridge, because it's going to be naturally more
Hmm.
vibrant than whatever is happening in the middle of the desert where it's going to be very quiet. So, but again, all of this fine tuning, again, it's being done faster and faster. So again,
Hmm.
you're looking at sometimes it's the setup you connected literally within a few minutes, 30, maybe 1 hour maximum. You start recording, you start recognizing patterns, and then fine tuning, depending the complexity of the cable, can be in the order of days. But it's not a big onerous task, because again, right now there's a lot of
Hmm.
history and experience that again is coming from other critical infrastructure, but now we're really capitalizing that so much work has been done. So now, when it comes to telecom industry, we have so much fiber. There's actually a lot of knowledge on how to deploy these things.
Yeah, so it's basically it's a mature technology. It's not like wireless sensing where either through cellular or Wi-Fi, we know it's possible, we know it works, but it's not really ready for prime deployment. We're still looking into this. This seems to be much more
Yeah,
um
we have been monitoring pipelines probably for 15, maybe 20 years. We have been monitoring power cables again for many years. For example, tunnels, so fire detection, it's a
mhm,
big thing. So right now you're in Europe, so all of the tunnels in Europe by regulation need to have fire detection systems. So those fibers that you may see
Mhm.
on the trays
Yeah.
on tunnels, there's going to be some of those filaments that are used for fire detection. And again, that has been used for a long time, using
So
distributed
basically,
temperature sensing.
what is new is that operators might now become more proactive in selling as a service rather than because I'm not maybe that's not the case, but I don't get a sense that that's already ongoing on a big scale from an
Yeah.
operator, from net
Yeah,
cable
it's still
operator.
not on
So
a big
that's the new
scale. I
thing
think,
more
yeah, I
than the
think
technology.
the big operators certainly have run different types of demonstration, different types of pilots in different
Mhm,
locations for
mhm.
different use cases. So I think there's definitely, I can say there's definitely a lot of awareness already on the capabilities of these types of systems.
Yeah, so that's actually quite good because again, they don't need to put new. So the capex is extremely limited because they're probably doing it already. So it's just a question of sharing and having a way to sell the data to have
Yeah, yeah. So
that
so
it
certainly
should be pretty
someone.
straightforward and trivial. I mean, it's not.
Yeah,
Uh,
those networks that have, let's say, some sort of permanent monitoring system for with traditional OTDR systems, those are primed for saying, well, I can also detect acoustics, vibrations with that cable. I can also detect temperature. I can also detect strain. So depending on the configuration of that cable in the environment or the
mhm.
geography where
Yeah,
that cable is, you can open basically the possibilities of what you can do with that asset. But basically, for us, it's as simple as adding. I'm going to call it an OTDR on steroids that just happens to detect changes in dynamic strain or changes in temperature. But it's just that I'm connecting to that same fiber with some
yeah, yeah,
jumper
yeah,
cable or whatever into that
yeah.
network.
Yeah, and it's reliable and there's no privacy issues. I mean, well, most sensors do not. I mean, if you measure temperature for any other sensor, it's not a problem. But if you want to measure, for instance, traffic, and you have I mean, if whenever you use cameras to track things, then you have a
Mhm.
privacy issue, obviously, no matter what you.
Yeah.
And
Yeah,
yeah,
yeah, and this is very complementary
just
like that.
like
There is,
yeah.
for example, we use these tools as a virtual, I'm going to call it the virtual perimeter, so even the
Mhm.
virtual border. So now there's borders that are using fiber to monitor when people are crossing, those when they're crossing between countries. So what happens there is that you mentioned the example of the camera. So yeah, cameras are powerful, but you need to have a lot of cameras.
Yes.
Basically, when you have a fiber, you have a very long linear asset, and I literally can say, oh, I can detect someone at meter one or at meter two, depending on how I configure my system. So it gives you literally a very long antenna. And what has happened is that sometimes we use, knowing the limitation on the poor density of cameras, we can actually use the fiber to enhance that
Yeah.
type of service because we can say, well, we're not going to have someone looking at the camera or looking at the video 24/7, but we can trigger an alarm with the fiber and then point the closest camera to that location. Or
Right,
we
right.
can point a drone to go and fly to that location and see what is happening. So again, these are again all the area of third-party intrusion, perimeter detection. Again, it's a very, very big use case that has been around for fiber sensing for a number of years. And
Mm.
again, increasingly, we're
Yeah.
using it more and more. Now, for example, data centers, again, multi-billion dollar facilities. We need to protect those cables. So now you're feeding a lot of data, you're feeding a lot of power into these assets. We want to make sure that you don't have a mechanical excavator that all of a sudden cuts down the supply on this multi-billion dollar facility. So we're doing a lot of that from a security point of view, that are detecting someone
Yeah.
where they shouldn't be or detecting construction where it shouldn't be taking place. So we can again prevent an incident.
Yeah, absolutely. And yeah, if you have to put, say, fiber across the border around the data center, there is going to be a little bit of a capex, but compared to, putting
To what you
cameras
lose with
everywhere and
downtime,
doing something else. It's so much cheaper.
yeah, yeah,
So,
just mhm.
yeah, yeah. Well, and I guess now, again, from a telecom point of view, is that, how much of those assets are telecom access? I mean, networks that are already there or not. But I guess that there is an advantage anyway, because if it becomes more, something that the cable operators are selling, and then it's useful, and if there is already fiber, might as well use that rather than
Mhm.
put new
Yeah, it
one.
can be part of that added value to that service. So,
Yeah, no, absolutely. And I guess and obviously the cable operators have to do it just to protect their own assets. Which is
yeah,
like,
it's both
it's
here,
just amazing that you have something that you can actually use to protect yourself. It's not,
and this is part of the beauty of the technology, Monica, that certainly the cable operator, they can see the value as certainly reducing downtime on a
Mhm,
potential incident. So which is essentially operations,
mhm,
enhancing operations. But on the other end, again, the infrastructure that is connected by that fiber, they basically use it as a way to protect that asset. So it's a
yeah,
technology that actually can impact really all sites, And
yeah,
something that I have found is that sometimes, for example, the most dynamic or the most versatile of these sensors is the distributed acoustic sensing, DAS. And that thing, or you really can detect all types of stuff. There's been examples of detecting cicadas or detecting beetles.
hmm,
So sometimes, yeah, maybe the noise of cicadas it's a nuisance for the area lines because they're going to put weight on the cables, they can break. But they are also becoming incredible research tools for ecologists that all of a sudden they can use the cable to listen to different species that live around our infrastructure, So someone's noise is going to be someone else's signal, which is again something that is fascinating about this type
hmm.
of tools.
Yeah, and I guess that, obviously if you are a utility, you do it. You put fiber, and that's kind of sort of built in. You do it on purpose.
Mhm.
But if you are an ecologist, you obviously are not thinking about fiber as anything of any relevance to you, which it isn't, strictly speaking. But then again, if you learn, I guess that's a question also of the education to know, if you're not, if you study something in the environment, you don't necessarily even know that that's a
Yeah, and
possibility,
again,
where
this is
fiber
something where
is,
again
or
those
where, so that's great.
where we take advantage again those aerial fibers, or for example, so we've talked about a lot about subsea cables. There's a lot of beautiful work that has been done to detect and track marine mammals. So there's a lot
Yeah,
of
right,
right
right.
now work being done to detect whales. So certainly tsunamis, all types of
Hmm.
stuff using that subsea cable, which again it shows that that cable has a lot of value, not just for transmitting information, but for other aspects. So that's one.
Yeah. Well,
That's
Andres, this is also incredibly fascinating, because it's just like, there's just so much, and it really opens a new way to think of the infrastructure that we have there, that can be used
mhm.
for something else.
Yeah.
That's great.
No, thank
So
you.
I hope that, it just seems like, well, that is so interesting that we can do that. So that's been really fascinating talking to you. So thank you
No, no, no. Thank you.
for.
Thank you for the time. And any questions, send me an email and we can talk more.
Excellent. Well, thank you so much, and thank you all for listening in. I hope you find it as interesting as I did. It's not interesting, absolutely fascinating. So, thank you so much, and keep following us on your favorite podcast feed. Thank you.